On behalf of Physics Made Easy Kota, myself Diljit Kaur, I am presenting a new video lecture in our physics class on the chapter Magnetism and Matter. In this chapter, we are going to study about the magnets, type of magnets, bar magnets, properties of our magnets, magnetic field lines, different types of the magnetic field lines, and how to plot or represent magnetic field lines. So we are going to understand about the types of the magnet. There are the two types of the magnet. One is a natural magnet. It is a naturally occurring iron ore that can attract a small pieces of iron and steel. Second one is a man-made magnet, which is also known as an artificial magnet. So the natural magnet are available in nature and artificial magnet are regarded as a man-made magnet. So these are prepared in the factories or laboratories. Natural magnet have the irregular shape, so their poles are scattered, but in case of the artificial magnet, they have the proper shape. The north pole and the south pole are located at two specific regions. The strength of a natural magnet is well defined and difficult to change, but for our requirements we made the artificial magnet with a particular or a specific strength. Natural magnets are the long-lasting magnets, whereas the artificial magnets are man-made magnets, so their properties are time-bound. Natural magnets are of less usage, so for this we establish man-made magnets, or the human establish artificial magnet. They have the vast usage in laboratories, factories, and our daily life. Bar magnet is an artificial magnet. It is a rectangular piece of magnet having south and north pole of equal strength separated by a small distance. One end of a bar magnet act as a north pole and other end act as a south pole. Magnetic length of a bar magnet. The distance between the north pole and a south pole of a bar magnet is called magnetic length of a bar magnet. Magnetic length of a bar magnet is about 0.84 times the geographical length, which is known as the actual length of a bar magnet. Bar magnet is also called magnetic dipole. So now we are going to understand about the various properties of a bar magnet. There are the large number of the properties and we are going to study it one by one. The first property, that the like magnetic poles repel each other while unlike magnetic poles attract each other. So if you look at a picture, if we see the south pole of a magnet when come closer to the north pole of another magnet, attraction take place. But when south pole of a magnet is brought near south pole of another magnet, repulsion take place. So this states that like poles repel each other but unlike poles attract each other. This is one of the most important property to distinguish between a magnetic material and a magnet. A magnet attracts the iron piece as well as unlike pole of another magnet. Attractive property of a magnet cannot distinguish a magnetic material and a magnet. But if the polarity of a magnet is reversed, then it will repel the like pole of other magnet but attract the simple magnetic material like iron. Thus, we can say that repulsion is the surest test for distinguish between an iron piece and a magnet. A magnet attracts objects made of iron, nickel and cobalt, which is called as the attraction property of a magnet. Magnets also show the properties of pairs. As magnets have the two poles, north pole and the south pole, poles always exist in pair. If a magnet is cut into two pieces, it will result into two complete magnets, each having both north as well as south pole. They cannot be separated. And we already understood that the like poles repel each other but unlike poles attract each other. And also magnets show the property of alignment. That is, a magnet when suspended freely come to rest such that its north pole always point toward geographical north and south pole always point towards geographical south. Now talking about the strength with which a magnetic pole attracts the material towards itself, that is called as a pole strength. More the pole strength, more the power of attraction of a magnet. In fact, the poles are not exactly situated at the exact ends of the magnet, but a little inside nearer the ends of the magnet. Suppose we have a bar magnet and bring another small magnet closer to it, and that small magnet experience the force applied by the bar magnet. This force is applied up to the certain region, and that space or a region is known as the magnetic field. So magnetic field is a space around a bar magnet within which its influence can be experienced by a small magnet. Magnetic field can be represented with the help of a set of straight lines or curved lines. These lines are known as the magnetic field lines. In actual, these lines are not real but are drawn to visualize the real magnetic field or to understand the effect of the force in a particular region around a magnet. Two types of the magnetic field lines exist. The number one is a uniform magnetic field. In a uniform magnetic field, you can see that there are the straight lines which represent that it is a region which have a same strength of the magnetic field, and the magnetic field is in the same direction at all the points in the region. In uniform magnetic field, the magnitude as well as the direction of the magnetic field remain same. So that is the reason they are represented by the equidistant set of parallel magnetic field lines. Non-uniform magnetic field lines, as shown in the figure, it represent a clear difference between the uniform magnetic field and a non-uniform magnetic field. Non-uniform magnetic field means it is a space or a region in which the magnetic field have different strength at different points in the region, which means that the magnitude and the direction of magnetic field vary at different points in the region. So these magnetic field is represented by converging, diverging or unequal spaced field lines. A strong magnetic field is represented by closely spaced line, whereas weak magnetic field is represented by widely spaced lines. Here is a small activity. Take a bar magnet, sprinkle some iron filings around the bar magnet. After completing this step, press or tap the board gently. When you are doing this, you observe that iron filings arrange themselves in lines. These lines are known as the magnetic field lines. Magnetic field lines are continuous or closed curves traveling from North Pole to South Pole outside the magnet.